My name is Wemerson Marinho. This is a work from Instituto de Computação, Universidade Federal Fluminense in Brazil, together with Esteban Crua, Luis Marte, and Carla Marinho. I will frame this problem as a big educational problem and show how to use natural language processing to try to solve it, some experiments that we did with Brazilian National High School exam, and some conclusions. A big educational problem. Measuring how much a student knows is necessary to monitor how a student is progressing in mastering a skill, decide if they are prepared for more complex knowledge, and conduct fair selection in university admissions. But usually, traditional scores doesn't represent how much a student knows. We have a framework for this, it's eating response theory. It uses the student ability and three parameters that represent the statement of the question. When the ability of the student is much more than the difficulty of the question, the probability that the student will get the question right is 1. When it's much lower, the probability shows the random guessing probability. To find these parameters, you have to use them pre-test, but it's sometimes problematic because when you use pre-test, you compromise the safety of the exam because you have to expose your questions to a sample of the population. Sometimes the questions leak. And to conduct pre-test, you have to make great operational efforts. Historically in Brazil, they use University Talent Award to foster students to apply for this test. But even with this, sometimes you don't have the amount of students to have some statistical significance. And you have to pay almost $1,000 for the first 1,000 students to do this. It's a big amount of money just to get the parameters. If you have technology to infer the difficulty directly from text, it will mean you have cheaper and more frequent exams, you have a universal comparison scale to compare your students, and you allow small classes to use RRT in daily routines education. Nowadays, we have powerful artificial intelligence algorithms. So we will try to use them to try to predict these parameters. To do this, you have to make a computer read the questions. Traditionally, you have the back-of-word representation that you just point the presence or not of a word in a text. You can use CBOW or skipcan that is just a neural network that tries to predict a word using the neighbor words or predicting the neighbor words using the words. This is very useful because you can use the network representation as a vector that represent that word and embedding in computational terms. And the new architecture that they are used is transforming attention that use only dot products and make with this strategy, you can make very big architectures. So you can use neural networks with a lot of parameters, and they are very powerful. They are trained using masked language model that you get some tests and you erase some words and try to predict the missing words. Using this kind of task is not a new one in computer science. Older papers try to use CBOW or TF, EDF, or one-hot encoding of the words to try to correlate the text with the difficulty. The most recent ones try to use architectures using transformer attention. Usually they try to regress the text to the parameter B. That is the usual difficulty representation of the question. If you try to directly predict the regression with triplet ABC, you will have problems because P is much more important than E or C. So it's not so stable. Our proposed approach uses a public data set, use a massive amount of students, you use 52 million students in 13 years, use real exam questions, and so we are security against cheating, and they are complete statements, not on one-line questions. We tested CBOW approach and transformer attention approaches, and we use Portuguese. Almost all data sets in the literature are in English. The main difference of our approach is that we try to regress on the eating characteristic curve and obtain the triplet ABC as a byproduct. And this matters because with the three parameters, we can recalculate the exam scores, not only use the difficulty of the statement. Our approach is based on the following, or in spirit in variational autoencoder. You get a statement text and use a word vectors or a neural language model or a large language model to produce a matrix of the tokens and embedding them using a matrix of embeddings. So you use some reduced strategy to get a one-dimensional vector, and at the end of the network, you have a fully connected three parameters neural network, and we interpret each of these parameters as ABC after using an activation function, softmax for A, softmax for B, softmax for C, and interpret this as ABC, reconstruct an eating characteristic curve, and try to compare with our original eating characteristic curve. Our experiments. We use the ENEM microdata, is the high school Brazilian exam. So we use it from 2009 to 2021. And the last 2 years, we use it as test and the others as training. To get the parameters, you get the scores, each scores, you get the read rate of each score and producing an eating characteristic curve for each item. So we try to optimize to minimize the negative log likelihood for ABC using this equation. And you can extract the parameters this way, yes, because if you get the parameters obtained using this approach, we have almost the perfect correlation with the real scores, and the error is lower than 10 points from a set of 100,000 students. We tested CBOW approaches in Portuguese and multilingual, and used transformer attention in Portuguese and multilingual too. To pre-process the statements, we replace figures with the mark hash fig. We translate mathematical and chemical formulas using LaTeX and limit the test to the only 512 tokens. To reduce the matrix to one vector, we use a sequence of deep pyramidal convolutional neural networks. So at each cell, reduce the amount of the parameters by half. So we can put a lot of these cells one on top of another till we get one vector of one line. So we are able to produce 20 layers of neural networks with these parameters, pyramid cells, and at the end we have the dense tree that we interpret as ABC and try to compare with the eating characteristic curve. Our results from correlation, we can see that transformer attention models is better than CBOW models because they have much more parameters. And we see too that neural networks or large language models tested on the same language of the statements is better than using a much bigger neural network like Boom, for example. All models have positive correlation, and some of them we have a slightly better results than for very large protein case. So all other results we will base on this network, this neural network. Our results using the deep pyramidal convolutional neural network, you can auto-encode our inputs in training data. And in test dataset, you can see that we have aligning of the points near this perfect fit line, this yellow line. When we have the three parameters, we can recalculate the grade that our approach have and the grade that the ENEM attributes to each student. So we get a sample of 100,000 students from 2020 and 2021, and measure the error in points. You can see that language and encodes and humanities, they have lower error than nature and mathematics, because this statement have more equation and figures in both years. And if we can analyze the upper quintile, because ENEM is a selection exam, so they are interested in the first quartile of the sample. So we can see that this kind of sample have better results than all the sample. Using plotting the all results, we can see that this dotted red dot line have better results to the right than from the left. And this is from the model. Eating response theory use right questions to position your score. So if you have a random choice student, it's very difficult to distinguish that a student that have no ability at all. So you have results from language and codes and humanities and nature and mathematics. All these graphics almost represent with near the perfect fit that is dotted black line. So my conclusions is that you can use historical efficient exam to estimate eating theory parameters in new statements. A smaller neural network training on the same language of the statements may be better than using a giant multi-language one. And languages and humanities have better performance than mathematical and nature science. And we think that we can make better results if we use images. Maybe some of the statements have images, equations. We didn't use it embedded only for traducing mathematical equation, but we believe that the most important one, you get more data, so you have more stable results. Thank you all, and sorry for my mistakes on your language.